They say history is written by the victors, but what if the truth was buried with the fallen? Every secret leaves a trace, if you know where to look. This is The Broken Truth, decoding history, one broadcast at a time. The Broken Truth podcast, where history meets conspiracy. Every case tells a story, every story hides a lie. High in the subarctic wilderness of Alaska, a vast grid of metal antennas stands silent beneath the aurora-filled sky. This is HAARP, the High Frequency Active Auroral Research Program, a facility as remote and mysterious as the name suggests. Located near the tiny community of Gakona, Alaska, the HAARP site spans 30 to 40 acres with 180 towering antenna masts, each about 72 feet tall, arranged in a precise grid. At a glance, it resembles a giant radio farm sprouting from the tundra, with snow-capped Mount Wrangell looming in the distance as a silent witness. For decades, these antennas have captured the imagination of curious onlookers and the paranoia of conspiracy theorists. To some, HAARP is merely a cutting-edge science experiment to study Earth's upper atmosphere. To others, it's the epicenter of dark government secrets. Under the twilight skies of an Alaskan summer, whispers have carried tales of what HAARP really is: a weather-controlling superweapon, a mind-control device, even a machine capable of triggering earthquakes and trapping souls. Such claims sound like science fiction, yet they have spread around the world. Mind control, weather control, even controlling the will of animals. The myths about HAARP run wild. In 2010, Venezuela's President Hugo Chavez claimed a U.S. tectonic weapon linked to HAARP had caused the devastating Haiti earthquake. That same year, Iran's President Muhammad Ahmadinejad told the UN he believed HAARP was responsible for catastrophic floods in Pakistan. More recently, after the tragic Turkey-Syria earthquake of 2023, social media lit up with accusations that HAARP, an array of antennas an ocean away, was somehow to blame. Each time a natural disaster strikes or unusual weather occurs, the fingers point north to this Alaskan field of antennas. Fantastic claims indeed, but what is HAARP truly? Is it the ominous doomsday device of internet legend, or a misunderstood scientific tool? Tonight we open the gates to HAARP's story, separating fact from fiction. We'll journey from the realm of fringe conspiracies into the fascinating science of Earth's upper atmosphere. Through expert interviews, historical accounts, and a bit of myth-busting, we'll discover how a Cold War-era idea evolved into one of the world's most advanced ionospheric research facilities, and how it became a lightning rod for controversy. Welcome back to the Broken Truth podcast. I'm your host, Garrett, and this is The Science and Mysteries Above, where we explore the intriguing intersection of cutting-edge science and public imagination. In this episode, we demystify the high-frequency active auroral research program. Strap in for a journey into the ionosphere, that electrified edge of space, and into the tangled web of conspiracies it inspired. The HAARP facility lies on a 5,000-plus acre tract of land in interior Alaska, between the Wrangell Elias Mountains and the small towns of Glen Allen and Tok. It's far from any major city, deliberately so. In the early 1990s, when HAARP was conceived, this isolation was an asset. The site had minimal radio interference and a geomagnetically suitable location under Earth's northern lights. In fact, the land was originally acquired by the U.S. Air Force in 1989 for an over-the-horizon radar project, a system to peer over the Earth's curve for incoming Soviet bombers. The Cold War radar was never built, but the remote site found a new purpose as HAARP's home. If you visited HAARP on a normal day, you'd find it eerily quiet. There are no flashy signs of high-tech destruction, no lasers piercing the sky. Most of the year, HAARP is simply a silent pile of gravel sprouting antenna. As one writer put it, Songbirds flit among the spruce trees beneath the metal masts. Snow drifts around the grid in winter. Only when HAARP is running an experiment do those antennas come alive. Fed by rows of powerful generators, sending focused radio energy upward. But to curious minds, this silence itself can feel secretive. What are they doing out here? In recent years, to dispel the aura of mystery, the facility's operators have literally opened the gates. At an annual open house, locals, tourists, and even self-professed conspiracy theorists are invited to walk right in. On one sunny August day, about 260 people showed up. Gakona villagers, military families from Anchorage, a Japanese film crew, and indeed, a few skeptics with question. They wandered freely among the antenna forest, dogs on leashes sniffing around the gravel paths. Scientists and engineers stationed at various points happily explained the lab without walls that is HAARP. We want to be as transparent as possible, says Sue Mitchell, a former outreach coordinator for HAARP. Throw open the gate and show people what's here. My hope has been that by showing people what really goes on, the facts will speak for themselves. And yet, even with the gates open and scientists on hand, not everyone is convinced. It's not a weapon, and it couldn't be. Even if we made this whole array 10 times bigger, we still couldn't affect the weather with it. The way these high-frequency radio waves work, the atmosphere is basically transparent to them, so we can't push the lower atmosphere around. And as for minds, well, the human brain operates at much lower frequencies than what we transmit. HAARP's waves are meters long, totally different scale, so there's no way they can control minds. This is an explanation from McCoy, and his explanation echoes what scientists have been saying for years. HAARP's high-frequency signals can't directly influence the weather down here in the troposphere, where storms form, or fiddle with our brainwaves. In fact, by the time radio beam reaches the ionosphere, 100 miles overhead, its intensity is incredibly weak, less than 3 microwatts per square centimeter, far weaker than even the natural electromagnetic noise from the sun. As Dr. McCoy puts it, no, it's not a weapon. If we made it 10 times bigger, we still couldn't affect the weather. And minds? The electrical signals in the mind are very low frequency. HAARP is very high frequency, so there's no way. But here's the twist. If HAARP isn't an earth-shaking superweapon, what exactly is it doing? Why build such a powerful transmitter in the Alaskan wilds, and what do scientists hope to learn? To answer that, we need to venture up, above the clouds, beyond the reach of weather, to a mysterious region of the atmosphere that HAARP was built to study. HAARP's true mission is to study the ionosphere, a high-altitude layer of Earth's atmosphere, where the air thins into space and becomes electrified by the sun. If you've ever seen the northern lights, the aurora borealis, you've witnessed the ionosphere in action. Those shimmering curtains of green and red light are caused by charged particles raining down and energizing this upper atmospheric layer. The ionosphere is huge. It begins roughly 50 to 60 miles above us and extends to 600 miles or more. It's sparse, almost space, but not empty. Solar ultraviolet and X-rays constantly smack into the tenuous gases up there, ripping electrons off atoms and creating a soup of ions and free electrons. During the day, the ionosphere is dense with charged particles. At night, some recombine and the layers change. It's a region in flux, rising and falling daily, shifting with seasons, and pulsing with the sun's activity. For us down on Earth, the ionosphere plays an invisible yet critical role. It reflects and refracts radio waves, enabling long-distance radio communication beyond the horizon. Early radio pioneers discovered this by accident in the late 1920s. Stations could suddenly be heard hundreds of miles away at night because their signals were bouncing off a charged layer high above. That layer, later dubbed the Kennelly-Heaviside layer, or the E layer, was the first hint of the ionosphere's existence. In 1924, British physicist Sir Edward Appleton conducted a clever experiment in Oxford that proved these reflective layers were real. about 100 kilometers, or about 60 miles up. Appleton measured radio echoes from the sky and even determined the heights of these different layers. The E layer around 50 to 100 miles, and the F layers are higher up. His ionospheric research earned him the Nobel Prize in 1947, and it laid the groundwork for modern radio and radar technology. Knowing the ionosphere was there was one thing. Understanding it was another. This sky mirror for radio waves proved to be highly variable. It's influenced by the sun's 11-year solar cycle, by day-night cycles, by geomagnetic latitude. It's different near the poles versus the equator, and by random solar events like flares. During intense solar storms, the ionosphere can become turbulent or disturbed, disrupting radio signals and GPS navigation. In fact, bursts of solar activity can pump so much energy into the ionosphere that radio communications black out and navigation errors increase. For militaries and global communications, that's a big concern. The ionosphere is also tricky to study because it's too high for balloons and too low for satellites to orbit in. Satellites in that region would quickly fall back to Earth due to drag. For a long time, scientists' knowledge came from remote sensing. Ground-based radars called ionosones pinged it to measure heights, and occasional rockets or satellites skimmed its edges. We got snapshots, but not the whole picture of how this region behaves. Enter the concept of active experimentation in the ionosphere. If nature's variability makes it hard to predict or measure, why not poke the ionosphere and see how it responds? In the 1970s and 80s, researchers in Europe and the Soviet Union did exactly that, with early ionospheric heating facilities. The Trosmo, Norway, the EISCAT facilities, scientists began transmitting HF radio waves into the sky, deliberately perturbing small patches of the ionosphere and observing the effects. In the Soviet Union near Nizhny Novgorod, a similar project called Sura started in 1981. Sura could pump about 190 MW of effective radio power into the sky, and Soviet researchers soon discovered the effect of generating low-frequency waves by modulating the ionospheric current, essentially using the ionosphere as a giant antenna. These pioneering projects showed that by heating a region of the ionosphere with HF radio waves, you could induce all sorts of interesting phenomena: artificial auroras, very low-frequency radio signals, plasma turbulence, and more. The ionosphere became a natural laboratory, one without walls or boundaries, where experiments could be done on a grand scale. It might sound wild to heat part of the sky just to see what happens, but scientifically it was groundbreaking. As one account notes, using the ionosphere as a plasma laboratory let researchers observe processes in slow motion, that in a small lab, plasma would happen too fast to see. And unlike a controlled lab, this lab is huge and connected to the rest of near-Earth space, so experiments could mimic or probe natural phenomena directly. By the late 1980s, the United States realized the value of such a facility for both pure science and potentially practical applications. The US had done some smaller heating experiments at locations like Arecibo, Puerto Rico, and Fairbanks, Alaska, HIPAS facility. But nothing on the scale of Sura or IceCat. The seed was planted to build the most powerful ionospheric research instrument in the world. And where better to do it than Alaska? Remote. To avoid interfering with civilian communications, Aurora rich, and conveniently on US soil. The timing was right. The Cold War was ending, freeing up some defense research budget, and a powerful Alaskan senator, Ted Stevens, was eager to bring high-tech projects to his state. In 1990, HAARP began as a joint-funded project by the U.S. Air Force, Navy, and DARPA, the Defense Advanced Research Projects Agency, with the University of Alaska Fairbanks as a partner. Construction started in 1993, and by 1995, the first modest array was in place. 18 antennas arranged in a grid, like a little sibling to the grand design that was to come. HAARP was built in phases. The initial test bed was small, a 6x8 array of 48 antennas, outputting about 360 kilowatts of power in 1994 to 95. Think of it as a pilot light, Over the next decade, more funding and hardware rolled in. By 1999, HAARP was operating at about 0.96 megawatts with 48 antennas, enough for early high-quality research. But the ultimate goal was far grander. In 2003, with the support of Senator Stevens, often called Uncle Ted in Alaska, for his ability to channel federal dollars to the state, HAARP officially opened its doors as a user facility. And by 2007, the array reached its full design, 15 columns by 12 rows and antenna units, 180 antennas in total, fed by 360 high-frequency transmitters. The antennas stand on a gravel pad in symmetric rows. Their cross-dipole design, looking a bit like metallic spiders, on stilts. When wired together as a phased array, these antennas can act in unison, focusing radio energy into a steerable beam in the sky. The numbers are impressive. HAARP's final generation transmitters can deliver 3.6 million watts of radio power into the antenna field. Through the magic of antenna array gain, that energy is concentrated so that effectively, up to about 9.6 million watts, and in certain calculations, an ERP or effective radiated power of hundreds of megawatts can be directed upward. In simpler terms, HAARP can pump an unusually strong radio signal into a small patch of the ionosphere. The frequency range is 2.7 to 10 megahertz, just above the commercial AM radio band and below CB radio frequencies. The transmitters can be tuned within allocated subbands in that range so as not to interfere with other users, and they can emit either continuous waves or rapid pulses as short as 10 microseconds. Power like that requires serious infrastructure. HAARP is powered by 5 giant diesel generators, reportedly salvaged from military ships, 4 from old Navy tugboats, and 1 from a locomotive engine. When all are running, they generate on the order of 10 MW of electrical power to feed the transmitters and support system. Each transmitter unit is housed in a small shelter at the base of an antenna, and there are dozens of these little transmitter shacks lined up in the grid. In frigid Alaskan winters, just keeping all those electronics warm and dry is a challenge. It costs around $250,000 each year just to heat the HAARP facilities through winter. The antenna itself covers about 33 acres, roughly the size of 20 to 25 football fields. The site is fenced, with a few support buildings, a control center, and storage, but the antennas dominate the view. They are arranged on a ground grid with spacing optimized for the HF wavelengths. From above, it looks like a giant checkerboard of crosses. HAARP's main instrument is called the ionospheric research instrument, essentially the entire transmitter antenna system. But HAARP isn't just a transmitter. To observe the effects of transmissions, the facility is equipped with a suite of sensitive diagnostic instruments. These include high-power radar receivers in VHF and UHF bands to monitor ionospheric echoes, a digisonde HF radar to profile ionospheric layers overhead in real time, like a depth sounder for the sky, flux gate and induction magnetometers to measure minute changes in Earth's magnetic field during experiments, sensitive optical cameras and imagers to capture faint glows in the night sky, often tuned to specific auroral colors, like the green oxygen line, in case HAARP induces an aurora or air glow. Radio receivers and spectrum analyzers to pick up any frequencies generated in the ionosphere as a result of heating. For example, HAARP might simulate the ionosphere to emit secondary radio waves that can be detected on the ground. In short, HAARP can transmit and listen. A typical experiment might go like this. Researchers pick a target spot in the ionosphere, say 100 miles above. The array is phased to point there. HAARP's beam can be steered up to 30 degrees from vertical in any direction, giving a fair overhead reach. They choose a frequency, perhaps around 5 megahertz, that resonates well at that altitude. The transmitters fire in unison, sending a focused HF beam upward for, say, 30 seconds. During that blast, the radio energy heats the electrons in that patch of the ionosphere slightly, raising their temperature by maybe a few tenths of a degree, and pushes the plasma out of equilibrium. Then the transmitters stop and the instruments watch. What happens as the ionosphere relaxes back to normal? The researchers might repeat this on and off cycle, pulse and observe, and vary parameters to test their hypotheses. Importantly, even at full power, HAARP's effect on the ionosphere is tiny and transient. One HAARP scientist explained it with a backyard analogy. It's like putting a space heater in your backyard on a cold day. If you stand right in front of it, you feel some warmth. But the moment you turn it off, the warmth dissipates almost immediately. In the same way, when HAARP's transmitters shut down after an experiment, the ionosphere cools back down and returns to its natural state within seconds to minutes. There's no lasting change, no cumulative effect, just a temporary poke. The intensity of HAARP's beam up there is far weaker than the intensity of sunlight by many orders of magnitude, and even weaker than the routine fluctuations the sun causes in that region daily. So HAARP is essentially a research tool, a very powerful, very specialized radio transmitter that allows scientists to conduct active experiments in the ionosphere. But what kinds of experiments? And why would anyone fund such a thing? This is where science and defense interests converged, and where HAARP's story gets really interesting. Let's explore some of the real applications and discoveries HAARP has contributed to. The part of the story that doesn't always make the headlines, but shows why so many scientists were excited about HAARP long before the conspiracy theorists noticed it. Despite the wild rumors, HAARP's legitimate applications are plenty fascinating on their own. From the start, the program's stated purpose was twofold: basic research of the ionosphere's processes and exploring potential ways to enhance communications or surveillance using ionospheric interactions. In other words, learn how this region works and see if that knowledge can be used to our advantage. For example, in making radio transmissions more reliable or in detecting things otherwise hidden. Let's break down some key experiments and capabilities that HAARP has demonstrated. 1. Generating extremely low frequency waves. One of HAARP's most novel tricks is to create low frequency waves, radio signals without a huge antenna on the ground. Normally to transmit at say 30 kilohertz or 300 hertz, very low frequencies, you'd need an antenna miles long. But HAARP can modulate the ionosphere itself to act as the antenna. By pulsing its high frequency beams in patterns, HAARP can drive electrical currents in the overhead auroral region, the auroral electrojet, a natural current flow in the ionosphere. This causes the ionosphere to emit VLF and ELF radio waves that can propagate long distances. Why does this matter? Because VLF and ELF can penetrate deep into water and Earth. The US Navy has long sought reliable ways to send messages to submerged submarines. One way is via VLF signals, which can reach sub-hundreds of meters underwater. HAARP proved it could induce a VLF signal in the ionosphere that could be received across the globe. In one experiment, the HAARP array heated a part of the ionosphere that in turn acted as a low-frequency antenna that could send an ocean-penetrating signal to a submarine. That signal was basically a ping, telling the sub to surface for a full message. It's like using the sky as a giant wireless transmitter for subaquatic communication. This capability has obvious military usefulness, submarine comms, but also scientific value. VLF waves are used to study the Earth's magnetosphere and even the deep Earth. 2. Improved over-the-horizon radar and radio communication. HAARP can create artificial reflecting layers in the ionosphere. Some experiments, HAARP's high power caused ionization levels to increase in a layer just below the normal ionosphere, effectively forming a temporary new mirror for radio waves. By doing this repeatedly, researchers found they could descend an artificial plasma layer gradually to low altitudes. Why would anyone do that? Consider radar. A low ionospheric layer could reflect higher frequency radar signals over the horizon with better precision. Or, for communications, you might be able to bounce signals off a tailor-made layer to reach distant receivers more reliably. One scientist noted that HAARP's energy density was enough to realize ideas previously thought impractical, offering potential for enhanced over-the-horizon radar and tailored long-distance radio links. This is still a research concept, but it shows how the ionospheric engineering that HAARP made possible on a small patch of sky at least. 3. Studying space, weather, and radiation belts. The military has another interest up there, protecting satellites and high-flying aircraft from radiation. The Earth is surrounded by the Van Allen radiation belts, zones of charged particles trapped by our magnetic field. A nuclear explosion in space or a big solar storm can inject high-energy electrons into these belts, posing a danger to satellites. They can fry electronics, and even power grids through geomagnetic storms. The Air Force has looked at whether we can accelerate the cleanup of radiation belt particles. One idea is to use VLF waves, like those HAARP can generate, to disturb the trapped electrons and knock them out of the belts. HAARP experiments have indeed been used to investigate how VLF and ELF waves can precipitate electrons from the Van Allen belts artificially. Think of it as flushing the charged particles down into the atmosphere, where they'd be harmless, to potentially mitigate the aftermath of a high-altitude nuclear event or severe solar storm. HAARP's unique ability to inject specific frequencies into the magnetosphere made it a one-of-a-kind tool for this research. 4. The artificial aurora and air glow, one of the most visually intriguing experiments, making the sky light up on command. Under certain conditions, HAARP can stimulate faint air glow and artificial aurora by pumping enough energy at the right altitude. HAARP excites oxygen atoms, causing them to emit the same green light seen in the natural aurora. Usually this glow is subvisual, too faint to see with the naked eye, but sensitive cameras easily detect it. On rare occasions with perfect dark skies and sensitive equipment, a dim little patch of red or green light has been observed in the sky directly above HAARP during experiments. Scientists like Dr. Chris Fallon have used this artificial aurora to study auroral physics in a controlled way. It's as if they created a tiny aurora borealis on demand to test models of how particles and waves interact in that region. Despite conspiracies, this is not ripping a hole in the atmosphere. It's a gentle glow, comparable to, say, the brightness of a dim star. 5. Probing the Earth and near-Earth objects. In 2022, HAARP entered a new era of experiments reaching beyond Earth. In a NASA-partnered test, scientists used HAARP to bounce signals off an asteroid hundreds of thousands of miles away. The idea was to see if we could detect subsurface features of asteroids by reflecting low-frequency signals off them, a potential technique for planetary defense to characterize asteroids that might threaten Earth. HAARP transmitted a coded signal toward a passing asteroid, and radio observatories listened for that faint echo. Around the same time, HAARP even attempted the unprecedented Jupiter bounce, directing signals at Jupiter's ionosphere, just to see if our ground systems could receive the return from a different planet. These ambitious experiments are essentially stretching HAARP's capabilities to act like a gigantic space radar. While results are pending or modest, receiving such distant echoes is extremely challenging. The fact that HAARP was involved highlights its status as versatile research instrument. 6. Basic plasma physics. Many experiments simply further our understanding of plasma processes. HAARP has been used to study plasma instabilities, electron acceleration, and the formation of structures in the ionosphere. For example, HAARP researchers have observed plasma lines, emissions at harmonics of the transmitted frequency that give insight into electron densities and temperatures. They've studied a phenomenon called simulated electromagnetic emission, where HAARP produces a signal and the ionospheric plasma itself starts to emit secondary frequencies, revealing properties of the plasma. Sorry to interrupt your regularly scheduled podcast, but this episode is brought to you by the Broken Truth merch. Support the show. Wear the truth. Official Broken Truth podcast merch is live now. Links in the description. And since you've made it this far in the episode, comment hashtag Broken Truth and leave us a 5-star review on your favorite platform. Because when you speak up, the algorithm listens. And so does the world. They've investigated gyro-frequency heating, where the transmission is tuned to the cyclotron frequency of electrons in the Earth's magnetic field, causing interesting wave-particle interactions. They've looked at spread F irregularities, the cause of radio signal scintillation and GPS errors, by perturbing the F layer and watching how echoes become fuzzy. All these studies get written up in academic journals. Indeed, HAARP data has yielded hundreds of scientific publications over the years. And importantly, HAARP has always shared these results openly. Despite military funding in its early years, the researchers involved published their findings in public journals like Geophysical Research Letters and Journal of Geophysical Research. Scientists from around the world, including those from adversary countries, have worked on site. In its heyday, HAARP even ran summer schools for graduate students, training the next generation of space physicists with hands-on experiments. The project's designers stressed openness, no secret experiments, all the activities logged and available to the public. Foreign scientists are welcome, and that tradition continues under the University of Alaska today. Each year, an open house for the public and continuous academic collaborations. In sum, the real HAARP is a remarkable scientific facility that has advanced our understanding of how the Earth and space environment are coupled. It helped figure out how to communicate with deep-sea submarines via the sky. It tested ways to potentially mitigate radiation hazards to satellites. It created ghostly auroras to examine fundamental physics. It even served an educational mission, inspiring awe and curiosity about a part of nature that is normally invisible. Yet, ironically, it is HAARP's very power and uniqueness that also bred suspicion. A facility that can beam radio waves into space and make the sky glow was bound to raise eyebrows, especially among those inclined to distrust government projects. Add in the fact that HAARP was initially built by the military in a remote location and had a somewhat cryptic name, and you have a recipe for conspiracy theories. As one Alaska science writer quipped, scientists themselves were a bit to blame for the allegations of weirdness. They used an acronym HAARP, which added to the mystery. A mysterious name in an obscure field of research made it easier for outsiders to speculate wildly about what HAARP might really be up to. So now, having seen the truth of HAARP's capabilities, let's confront the wild side. The myths and conspiracy theories that turned HAARP into a global boogeyman. Where did these ideas originate? And what do experts say to debunk them? HAARP entered the public consciousness in the mid-1990s, not through scientific journals, but through the whispers of conspiracy forums and late-night talk radio. Perhaps no single publication fanned the flames more than a 1995 book ominously titled, "Angels Don't Play This HAARP: Advances in Tesla Technology," written by Nick Begich, Jr., an Alaskan local's son, and Gene Manning. This book suggests that HAARP was far more than a benign research project. It linked HAARP to the legendary inventor Nikola Tesla, speculating the facility might realize Tesla's old dream of a wireless energy transmission, or weaponize it. The authors posited that HAARP could be tapping into the ionosphere to manipulate weather and even people's minds, all under a cloak of military secrecy. The evocative title itself, playing on HAARP as a gentle instrument versus HAARP as a dangerous tool, captured imaginations. Angels don't play this HAARP, indeed, implying only dark forces would. Around the same time, legislators and activists began voicing concerns. The Alaska State Legislature held hearings about HAARP in the late 1990s, responding to the constituents' fears that this giant transmitter might be harming the environment or health. And in Europe, the European Parliament took notice. In January 1999, the European Parliament's Subcommittee on Security and Disarmament included HAARP in a resolution about environment security and foreign policy. They expressed worry that HAARP could be manipulating the environment for military ends. They even called for a global ban on weapons, which might enable any form of manipulation of human beings, in allusion to the mind control fears. Seeing HAARP referenced in an official EU document gave a sheen of legitimacy to conspiracy claims, even though the EU was mostly responding to public anxieties, not confirming them. Conspiracy proponents often cite this as proof that the government, or some government, admitted HAARP's dangers. It didn't help that HAARP's early years were under wraps of military operations. The site was on a secure U.S. Air Force property and not open to casual visitors, which for some was evidence of nefarious secrecy. As the internet blossomed in the 2000s, HAARP became a staple of conspiracy websites and forums. A quick search today yields millions of hits. Let's outline the top conspiracy theories about HAARP and their origins. The first being weather control. Perhaps the most widespread claim is that HAARP can control or alter the weather. This ranges from causing hurricanes, typhoons, and tornadoes, to inducing droughts or floods in targeted areas. For instance, after Hurricane Katrina devastated New Orleans in 2005, murmurs arose that HAARP similar technology had steered the storm. When Russia faced an unprecedented heat wave and wildfires in 2010, some officials insinuated Western weather modification via HAARP might be involved. The specter of weather control isn't new, but during the Vietnam War, the US did attempt cloud seeding to prolong monsoons via Project Popeye, and scientists have tried for decades to influence rainfall. But the conspiracists imagined something far grander, that HAARP's radio beam can alter jet streams, intensify storms, or trigger climate chaos on demand. An Instagram meme cited in a fact-check claim that by spraying particles into the sky and firing multi-trillion-watt beams from HAARP stations, operators could manipulate cloud cover and precipitation. Setting aside that HAARP's actual power is millions, not trillions of watts, and there's only one HAARP, not several, the notion sounds like a villain's monologue from a James Bond film. Two being earthquakes and tectonic weapons. The leap from weather to geology came dramatically with events like the 2010 Haiti earthquake and the 2011 Japan earthquake and tsunami. After Haiti's disaster, Venezuela's Hugo Chavez publicly accused the US of testing a tectonic weapon, implying the Haiti quake was caused intentionally, possibly by HAARP or something like it. Iranian media and others echoed similar claims. The devastating magnitude 9.0 quake in Japan in March 2011 likewise spurred theories that it wasn't natural. Online, some pointed to strange cloud patterns or aurora-like lights seen before the quake as evidence of an electromagnetic weapon being used. More recently, as mentioned, the February 2023 Turkey-Syria earthquake triggered another wave of tweets and videos blaming HAARP, some even suggesting geopolitical motives. NATO punished Turkey via HAARP for being friendly with Russia. These theories often claim HAARP's ability to emit ELF waves could induce vibrations in Earth's crust, or that heating the ionosphere could somehow trigger fault lines. The science here is basically non-existent. There's no known mechanism for radio waves to trigger earthquakes, and seismologists universally dismiss the idea. Earthquakes result from tectonic stress built up over decades. You can't just shake the ground with a radio beam and cause a fault to slip. But the coincidence of HAARP's existence and any big earthquake is enough for conspiracy narratives that refuse geologic reality. The third being mind control and behavior influence. The idea that HAARP manipulates human thoughts likely stems from a mix of misunderstanding and historical memory of shady experiments. People hear ionospheric research and perhaps think of the ionosphere's role in reflecting radio signals, including those that could be used for long-range broadcasting. Indeed, during the Cold War, the US and Soviet Union both explored the potential of radio frequency energy affecting human biology, leading to paranoia about psychotronic weapons. In the HAARP lore, some claim it can beam voices into people's heads or alter their mood on a massive scale. Former Minnesota Governor Jesse Ventura, a celebrity who dove into the conspiracist world, popularized this by flatly claiming HAARP is a mind control device. He even filmed an episode of his TV show Conspiracy Theory at HAARP's gates around 2009, dramatically speculating about its powers. The mind control theory often cites that HAARP's radio frequency can be tuned to brainwave frequencies. However, this is a misunderstanding. Human brainwaves are in the low hertz range, 0.5 to about 40 hertz, which are extremely low frequency electromagnetic oscillations. HAARP's lowest possible frequency, 2.7 megahertz, is 2.7 million hertz. That's in the HF shortwave range, completely different regime. As Dr. McCoy explained earlier, electrical signals in the mind are very low frequency. HAARP is very high frequency. There's no way they could control minds. Moreover, HAARP's waves are directed up at the sky, not at populations on the ground. Still, imaginations run wild with notions of HAARP generated mass hypnosis, or even controlling weather to controlled minds. For example, causing depression via gloomy weather, a convoluted theory indeed. Some miscellaneous conspiracy claims. HAARP has been blamed for virtually anything unexplained. Some fringe theories say it can disable satellites or shoot down missiles by zapping the atmosphere. In reality, HAARP's HF beam can't reach satellites in any damaging way. By a 300-kilometer altitude, the signal is exceedingly faint. Others tie it to the chemtrails conspiracy, claiming HAARP works in tandem with airplane contrails laced with chemicals to modify weather or influence people. One viral post pointed at contrails as evidence of weather engineering and said HAARP's multi-trillion-watt beams heat those particles to do weather control. Again, false on multiple levels, as contrails are just ice crystals, and HAARP isn't near most flight paths. Some of the truly bizarre stories include the notion that HAARP can pull meteors or asteroids. Nope. It can barely ping them as an experiment, certainly not tug them. Or that it's being used by shadowy elites to implement mass population control. At an Alaska open house, one local quipped about a rumor that HAARP caused caribou to walk backwards. Comedic example of how far into the absurd the folklore goes. It's crucial to understand that these theories often persist due to confirmation bias and misunderstanding rather than actual evidence. Whenever an unusual natural phenomenon occurs, be it a dramatic aurora display, a rare cloud formation, or a devastating disaster, those already primed to suspect HAARP will say, aha, there it is. They score for coincidental timings. Perhaps HAARP was running an experiment the same week, which isn't hard to imagine because HAARP has had many campaigns. But correlation isn't causation. They'll point to technical documents out of context. For instance, patents filed by HAARP's initial developers that mention weather modification, or military reports about ionospheric research, and read them as devious plans. A classic reference is a 1990 patent by an Arco power technology scientist, an early HAARP contractor, describing a method for altering a region of the atmosphere via RF heating. Conspiracists cite that patent as proof that HAARP is a weather modification system, when in reality it was a speculative patent. Many patents are theoretical. That never translated to an operational system. Let's hear directly from experts regarding these claims. We asked Dr. Peter Dyson, an emeritus professor and ionospheric expert, whether HAARP can manipulate the weather. Professor Peter Dyson says, HAARP has no effect on weather systems, he told us flatly. HAARP transmits high-power radio waves in the range of 3 to 30 megahertz, which are absorbed by the ionosphere, causing heating and turbulence in the ionospheric plasma. The ionosphere extends upwards from about 60 kilometers, well above Earth's weather systems. So HAARP has no effect on the weather systems. It heats the ionosphere around 100 kilometers altitude and above, depending on frequency. In other words, HAARP and the troposphere, where our weather happens, are operating in different spheres, literally. The storms ride far below, untouched by what HAARP does at the edge of space. He also debunked the wildly exaggerated power figures. HAARP's transmitter power is not multi-trillion watts, as claimed in some conspiracy image, but 3.6 megawatts, with the transmitted beam spreading out as it propagates. By the time the signal reaches the ionosphere, the intensity is less than 3 microwatts per square centimeter. Once the beam is turned off, the heated region of the ionosphere soon returns to normal. In short, HAARP's effect is feeble in the scheme of nature, millions of times weaker than the sun's influence. And nothing of that reaches the lower atmosphere meaningfully. On the idea of HAARP as an earthquake machine, we spoke with geophysicist Dr. Jane Allen, a fictional expert for this illustration. I've seen no credible evidence or physical mechanism for HAARP or any ionospheric heater to trigger earthquakes, she states. The energy involved in an earthquake is astronomical. The Haiti quake, for instance, released as much energy as hundreds of thousands of nuclear bombs. The energy HAARP emits is minuscule by comparison, and it's dissipated in the upper atmosphere. There's no pathway for that to somehow concentrate and break a fault line. We do monitor natural signals like electromagnetic precursors to quakes, but those are tiny and localized. Nothing like a directed beam causing a quake. Indeed, the consensus of the scientific community, the USGS earthquake researchers, is that human technology cannot induce large earthquakes remotely. Even our biggest underground nuclear tests only affected small regions and did not trigger major earthquakes elsewhere. The HAARP earthquake theory often cites that strange lights or clouds appear before quakes, a well-documented phenomenon, likely due to electrical effects from the rocks under extreme stress, so-called earthquake lights. There's no evidence linking those to HAARP, except in imaginative YouTube videos that draw a connection where none exists. And what about mind control? Could HAARP be sending subliminal messages or tampering with human brains? For this, we refer back to Dr. Chris Fallon, who has addressed such concerns. Generally, space physicists focus on regions more than 60 miles above our heads, where HAARP's radio waves are 100 times weaker than those from mobile phones, he says. The implication, if you're not worried that your smartphone right next to your head is controlling your mind with its radio waves, you definitely shouldn't be worried about HAARP's far fainter signals far above. HAARP's frequency isn't tuned to brainwaves, and it can't beam specifically at a person or city. It illuminates a broad patch of sky. As a tongue-in-cheek demonstration of openness, HAARP's team even once allowed a TV crew to stand among the antennas while the facility was operating, with proper safety measures. Nobody's behavior changed except maybe their amazement at hearing the buzzing of the radio signal on their handheld radios. Nevertheless, the myth of mind control via ELF waves may also stem from historical truth. Governments did experiment with psychological warfare techniques like Project MK Ultra in the 60s, which involved drugs and other means, not HAARP, and the Soviet Union's infamous woodpecker signal in the 1970s. An over-the-horizon radar spooked people globally in its constant tapping noise on shortwave bands, inspiring paranoia about what it was doing. The mind tends to fill unknowns with fears, and HAARP, to the layperson, was as big as an unknown for a long time. It's worth noting that the HAARP scientists themselves often found the conspiracies frustrating, yet somewhat ironic. They devote their careers to unraveling the complexities of the ionosphere, publish openly, and even they struggle to convey to the public what exactly they do, because it's so complex and abstract. As Dr. Fallon noted, most of the real information about HAARP is contained in an open academic literature that Google does not usually present in typical searches. The internet instead surfaces the sensational. He and others have taken to social media in recent years to share when HAARP is transmitting, even inviting ham radio operators and hobbyists to listen in to the signals. In one campaign in 2017, Fallon's live tweet about HAARP operations garnered huge interest. Thousands of people around the world tuned in to hear the eerie chirps and tones of HAARP on their shortwave radios, proving that transparency can generate fascination rather than fear. Bob McCoy, the UAF scientist who now oversees HAARP, has calmly engaged with visitors who are skeptical. People like conspiracy theories, he mused. People like UFOs. No matter what you do, no matter how many years you go without conclusive evidence, people still believe. And indeed, at the HAARP open house, one local man, Al Zahalski, voiced a sentiment not uncommon in the conspiratorial mindset. Does it make rain? Who's to know, he said. The government tells you some things and the media tells you another. Even though it's open to the public, there's a lot they don't tell you. We're not getting the whole truth. That altitude, that the truth is hidden behind layers of official statements, means that for some, no amount of evidence will suffice. If HAARP scientists say, we can't do that, the response is, well, they would say that, wouldn't they? One can understand to a degree why HAARP drew suspicions. It was a military-funded project studying something invisible and arcane. History has examples of governments conducting secret experiments on unwitting populations or developing clandestine technologies, and environmental modification for military use has been a concern. Hence treaties like the 1978 NMOD Treaty that bans weather warfare. HAARP arrived at a time of increasing awareness of climate change and ecological sensitivity. So the idea of humans meddling with nature resonated as fear. Moreover, the timing of certain disasters and geopolitical tensions provided a narrative some found emotionally satisfying. It's somehow more comforting, or at least more dramatic, to blame a malign human agency for a disaster than to accept that nature is beyond our full control. But as we have heard from the experts, the laws of physics place hard limits on HAARP that no conspiracy can overcome. At its core, HAARP is a giant radio transmitter, not fundamentally different from commercial radio towers or TV broadcast antennas, just larger and steerable. It cannot create earthquakes, mechanical energy versus electromagnetic, apples and oranges. It cannot inject enough energy into the weather system to influence a storm. The power disparity is immense, and it cannot control minds. Radio frequencies don't override our neural signals, and HAARPs aren't even the right kind. To further drive the point, HAARP is not the only facility of its kind. If ionospheric heaters were superweapons, then countries like Norway's IceCat and Russia's Sora had them decades earlier without causing apocalyptic havoc. In fact, in 2018, Chinese and Russian scientists conducted joint experiments using the Sora heater in Russia and a Chinese satellite to observe the ionosphere's response, causing a minor stir in the media. That experiment did perturb the ionosphere a bit. They noted some plasma disturbances, but again, nothing untoward what happened to ground weather or people, because the science works the same everywhere. HAARP is just more powerful and flexible, which makes it uniquely good for research, not for world domination. So with myths addressed, we can turn to the final chapter of HAARP's story. What became of this project after the military decided it was done? And what lies ahead for this once notorious, now increasingly celebrated instrument? By the early 2010s, HAARP had accomplished most of its original research goals for the US military. The Air Force and Navy, facing budget pressures, were ready to move on. In 2013, the Air Force Research Lab pulled funding, and HAARP went into mothballs, switched off the lights in June 2013. There was serious talk of dismantling HAARP, tearing down the antennas, scrapping the transmitters, and restoring the land. This prospect alarmed many in the scientific community. After all, HAARP was, and still is, the world's most capable ionospheric research facility. Losing it would be a huge blow to space physics research. In February 2014, the White House Office of Science and Technology Policy convened a meeting of agencies, the DoD, NSA, NSF, and others, to discuss HAARP's fate. The idea was to see if any other entity would take over. Dr. Bob McCoy, the director of UAF's Geophysical Institute, emerged as a key champion for saving HAARP. He rallied support from academic researchers and even got the University of Alaska's president on board to consider operating HAARP independently. McCoy recalls, even though it's esoteric and hard to understand, it's the best, emphasizing HAARP's unparalleled capabilities. The Geophysical Institute took a gamble. The university loaned funds to maintain HAARP for a few years, betting that grant money from scientific projects would pay it back. It was a risky move. $5 million per year in operating costs needed to be covered, just to keep it functional, but it worked. By August 2015, ownership of HAARP officially transferred from the US Air Force to the University of Alaska Fairbanks. HAARP got a second lease on life as a civilian-run research facility. With UAF at the helm, HAARP underwent maintenance and upgrades to bring it back online after a hiatus. In 2017, the UAF announced the facility was open to researchers on a pay-per-use model, meaning anyone with a valid scientific proposal and funding to cover the operating time could schedule experiments at HAARP. This democratized access has led to a renaissance in ionospheric research. Universities and labs from around the world, from Cornell and Stanford to the Naval Research Lab to international partners, have returned to do campaigns at HAARP. The facility that was nearly scrapped is now buzzing again, not with conspiracies, but with scientific inquiry. In late 2022, HAARP completed its largest research campaign ever, involving 13 different experiments over 10 days. Some we mentioned: the Moon and Jupiter bounce, the Steve Aurora-like phenomenon study, and continued studies of radio propagation. The National Science Foundation even awarded a 5-year grant to HAARP's operation as a national research center. This infusion of support validates that HAARP's scientific value is widely recognized. Looking ahead, what might HAARP contribute to in the future? Space mission support. HAARP could aid in testing communications or remote sensing techniques for future deep space missions. For example, understanding how Jupiter's ionosphere reflects radio waves might help planetary scientists interpret signals in that environment, benefiting missions to Jupiter like NASA's Juno orbiter. There's also interest in using ground HF transmitters in tandem with satellites to probe other planets' ionospheres, or even the lunar subsurface, by reflection experiments. Geophysical imaging. Some researchers propose using HAARP-like systems for subsurface tomography, essentially using low-frequency waves to map underground structures, oils, minerals, etc. By reflection, HAARP can create those ELF waves combined with sensors. It might remotely sense geological formations. The 2022 moon bounce experiment had a planetary defense angle. Analyzing the reflected signals could reveal an asteroid's composition or internal structure. If that principle holds, similar techniques could perhaps one day scan Earth's crust in seismically active zones to monitor stress changes. It's speculative, but it shows HAARP's potential in innovative sensing. Space weather prediction. By actively perturbing the ionosphere and seeing how it recovers, scientists refine their models of space weather dynamics. This has practical payoff in predicting natural ionospheric disturbances that affect GPS and radio. HAARP can simulate certain effects on a small scale of solar events, allowing testing of mitigation strategies for communication blackouts. Also, HAARP's continuous monitoring instruments provide data that complement satellite observations of the Sun-Earth environment. Education and inspiration. HAARP stands as a powerful tool to train new scientists in radio science, space physics, and engineering. Graduate students regularly get involved in campaigns, learning how to conduct big experiments and analyze unique datasets. There's even outreach, because HAARP's transmissions can be picked up by ham radio operators worldwide. It engages the amateur radio community in scientific exercises. For instance, during HAARP experiments, HAARP will sometimes send coded messages or signals, and hams participate in receiving them, essentially turning into a citizen science project. In the end, HAARP's story is one of transformation. From a little-known military research project to a centerpiece of scientific exploration. It is ironic that what was once shrouded in suspicion is now literally flinging signals at Jupiter and inviting the whole world to listen. The journey hasn't been easy. Even after the transfer to UAF, HAARP's image problem persists in some corners. As recently as 2023, when natural disasters struck, HAARP's name trended on social media for all the wrong reasons. But the best antidote to misinformation is information. Each time HAARP opens up, be it via open houses, live tweets, or published research, it chips away at the aura of mystery. Perhaps one unexpected positive outcome of the conspiracy era is that it drew attention to HAARP that might not otherwise have been there. People who had never heard of the ionosphere became curious. Some conspiracy theorists, in trying to debunk the debunkers, ended up learning quite a bit of real science, and some members of the public, initially lured by dramatic claims, found themselves tuning into actual discussions about how our atmosphere works. Dr. Fallon noticed during an open experiment that despite Google's top results being conspiracies, public interest was broader and more positive than he expected. In pop culture, HAARP even made its ways into video games, TV shows, and music. The rock band Muse named a live album HAARP, playing off the sense of something ominous and grand. It's not often a scientific facility becomes a household name, albeit for strange reasons. But now that it has that name recognition, scientists are leveraging it to educate. The University of Alaska has a whole educational website answering HAARP FAQs, straightforwardly addressing the myths. Can HAARP control weather? With the simple answer no, an explanation of why. As we conclude, let's revisit the haunting image of the HAARP array beneath the northern lights. In the darkness, the 180 antennas could be mistaken for some alien forest, each tower silently probing the heavens. It's easy to see how some could look at that and dream up sinister plots. But consider another perspective. Those silent antennas are like giant scientific ears and fingers, listening to and gently touching a region of space that is usually beyond our reach. HAARP is an instrument, literally a scientific harp, that we pluck to understand the music of the ionosphere. The active aurora it creates is not a signal of apocalypse, but a neon signpost saying, "Here is knowledge being gained." In a world where climate change does pose real threats, and technological manipulation of environments is a serious ethical topic, it's perhaps easier to latch onto a single scapegoat like HAARP than to face complex realities. But as we've learned, giving in to unfounded conspiracies only distracts from the real issue. Meanwhile, the real science of HAARP continues, quietly, rigorously, and in plain sight for those willing to look. HAARP stands as a testament to human curiosity. Our willingness to build a machine in the middle of nowhere, just to ask, what happens if we do this? And contrary to the doomsdayers, the answers have been enlightening, not endangering. The facility has navigated a strange path, vilified by some, celebrated by others, nearly extinct at one point, now reborn as a hub of discovery. The next time you hear HAARP mentioned in ominous tones, remember this episode. Think of the cadre of dedicated scientists in parkas and snow boots trekking across the antenna field to check connections. Think of the decades of research and published papers with titles about plasma lines and air glow, the quiet accumulation of knowledge. And if you have the chance on a clear Alaskan night during a HAARP experiment, look up. You might just catch a faint, otherworldly shimmer that says science is happening. The story of HAARP teaches us about more than upper atmospheric physics. It's also a story about communication between scientists and the public, between facts and fears. In the end, HAARP isn't an angel, a demon, but a tool. Whether that tool is seen as harp or a hammer depends on what tune we decide to hear. Here at Science and the Mysteries Above, we choose to hear the music of discovery. Thank you for joining us on this deep dive into HAARP. Until next time, keep questioning, keep exploring, and don't be afraid to venture into the unknown. It's the only way we turn the unknown into the known.
In a world built on hidden histories and half-truths, we've only just begun to peel back the layers. Because what you've heard tonight was never meant to be known, but you were meant to find it. If you're ready to go deeper, leave us a review, comment your thoughts, share this episode, and step inside the archives. Join the inner circle, where the real evidence is kept. This is the broken truth, because the truth isn't whole, it's broken.